Hi students, now we are going to solve the third numerical problem. A spherical soap bubble A of radius 2 cm is formed inside another bubble B of radius 4 cm. Show that the radius of a single soap bubble which maintains the same pressure difference as inside the smaller and outside the larger soap bubble is lesser than the radius of both the soap bubbles A and B. The problem is very lengthy but actually very simple. Now we have to read again and again till we understand what is the problem and what is asked in the problem. Now it is given that there are two soap bubbles. So when you blow a soap bubble, we get a spherical bubble, and inside the soap bubble there will be hollow space filled with air. So the soap solution is found only on the outer periphery. So how many free surfaces are there for the soap film is 2. One is the outer surface and the other one is the inner surface. So let us write the given quantities. The radius of the smaller bubble is 2 cm and the larger bubble is 4 cm. Okay, one is kept inside the other. Now, when both the bubbles are kept together, what is the pressure difference between the inside of the smaller bubble and outside of the larger bubble? We have to find out. And that is substituted by some other third bubble, another soap bubble whose radius is R. So we have to assume a soap bubble, a third one, okay, other than A and B, so that its radius is R. This maintains the same pressure difference as the given system of two bubbles. So first one, I will take the smaller bubble alone. So for smaller bubble, or I will write for the bubble A, the pressure difference delta P1 I will take for the first one, or delta PA I will take. So this is 4T divided by R1. 4T divided by R1. So R1 is equal to 2 cm. Afterwards I am going to substitute. So let us take this as equation 1. Now only for the larger bubble what is the pressure difference? So for the bubble B, okay, the pressure difference delta P for the second bubble B is equal to 4T divided by R2. So separately, when the single bubble A is outside, okay, this is the pressure difference. Similarly, only for the bigger bubble B, the pressure difference is this much. So let us take this as equation 2. Therefore, when the smaller bubble is kept inside the larger bubble, what is the pressure difference? Okay, the net pressure difference. The net pressure difference is delta P is equal to delta P for the bubble A plus delta P for the bubble B. So what is that equal to? 4T by R1 plus 4T by R2. So this is equal to what? 4T by R1 plus 4T by R2. This is equal to common factor 4T into 1 by R1 plus 1 by R2. So what is this? Therefore, delta P is equal to 4T multiplied by 1 by R1 plus 1 by R2, cross multiply R1 plus R2 divided by R1 R2. So this is R1 plus R2 divided by R1 into R2. Let it be as it is. Now this is what equation 3. Okay, now the same pressure difference is maintained by another bubble. You may call this as C, as you like. Okay, this is C. So the inner bubble is A, the outer bubble is B, and the third soap bubble is what? C, and its radius is what? R. It is also made up of the same soap solution only. So it is having the same surface tension. So now to maintain the same pressure difference, okay, so the pressure difference due to the bubble C, I will call it. This is given by the same pressure difference, is it not? So it must be delta P only. This third bubble also must maintain the same pressure difference as that of the combined bubbles. So delta P must be equal to 4T divided by R. So this is the equation 4. Now you look at the equations 3 and 4, left hand sides are same because the pressure difference between the two systems remains the same. I have to find R. So I am going to equate the right hand sides of equations 3 and 4. So 4T by R is equal to 4T into R1 plus R2 divided by R1 R2. Now 4T get cancelled. I take the reciprocal now. When I take the reciprocal, so R is equal to R1 R2. So R1 into R2 divided by R1 plus R2. Now the values 2 cm and 4 cm I am going to substitute. So what is R1? First numerator I will substitute. So this is 2 into 10 power minus 2 multiplied by 4 into 10 power minus 2 divided by 2 plus 4 into common factor is 10 power minus 2. Is it not? So this 10 power minus 2 I will cancel. 4 into 2 is 8. So R is now equal to 4 into 2 8 into 10 power minus 2 divided by 4 plus 2 is how much? 6. Okay. So 8 by 6 is what? 4 by 3 is 1.33. So this is equal to what? 1.33 into 10 power minus 2 meter. Okay. Therefore R is equal to 1.33 centimeter. Now what is to be proved here? We have to find the radius. Show that the radius of a single soap bubble, okay, is less than the radius of both the soap bubbles A and B. So what is the radius of the bubble A? 2 centimeter. And what is the radius of bubble B is 4 centimeter. So what is the radius of the single bubble which maintains the same pressure difference we have found is 1.33 centimeter, which is less than 2 as well as less than 4. So we can write like this, okay. Hence R is less than R1 and also R is less than R2. So this is just like a proof only. So we have proved that the radius capital R is less than R1 as well as less than R2. I hope you must have understood well. Fine.